Okay, 7.5 continues to be lots of fun. Direct variation. So direct variation, it usually looks something like y equals kx. Has a weird concept. Basically, when y goes up, x goes up. When y goes down, x goes down. They're sort of doing the same thing. They're directly related. They vary directly, direct variation. So in 314, it says A varies directly with B. A varies directly with B. So A, and K is sort of our relationship variable constant. So we'll just use K. So A varies directly as B. So that means how are A and B related? By some K. So this is them varying directly. We're going to talk about indirect next. Yay. Okay, 314. A varies directly as B. Okay. And then it says, so then this is our first setup, and then it says, when A is 16, B is 4. So we're going to try and solve for K. So when A is 16, B is 4. So let's solve for K. Get K alone. And so K is equal to 4. So we figured out what K is, and then they say find the equation that relates A and B. So we're going to rewrite that first equation as A equals, and what was K? K was 4. 4B. Aha. Okay, that was weird. Let us try, I guess we'll try 320. Let's see how this goes. I haven't read the problem. I should probably read the problem before I hit record. So we'll see how this goes. 320. The length that a spring stretches varies directly with its weight. So there's length and there's weight, and they vary directly. So length is equal to kW. So length and width vary directly with each other. Okay. When Sarah placed a 10-pound watermelon, 10 pounds is the weight, the spring stretched 5 inches. Okay. So let's figure out what K is. So we get K alone. So the length was 5 when the weight was 10. Get K alone. So K is 1/2. So go back to our original and plug the new value of K of 1/2, and we get L is equal to 1/2 W. Okay, what was this? 320. A, write the equation that relates the length of the spring to the weight. So here's part A. Part B, is there part B? B. What weight of watermelon would stretch the spring 6 inches? So the length would be 6. So 6 equals 1/2 W. So you plug in 6 for the length. We're trying to figure out the weight of the watermelon. So to get rid of that 1/2, I guess I would multiply both sides by 2. So that would make the 2 and the 1/2 disappear. So the weight would be equal to 12. Aha. Okay. Now let's try inverse variation. Since direct variation made total sense, inverse. So direct, did I say indirect before? I meant inverse, my bad. So now inverse is y equals k over x. Aha. So generally speaking, if it's an inverse relationship, as y goes up, x goes down. If y goes down, x goes up. So that's inverse. Okay, so let us try 324. 324 says P varies inversely with Q. Okay, so P and Q vary inversely. Again, we just use K traditionally for the constant when we're describing direct and inverse variations. Okay. If P's with Q and P equals 2 and Q is 1. P is 2, Q is 1. Okay, so let's solve for K. So Q is 1. 324, Q is 1. Okay. So, K over 1 is basically just K. So K is basically equal to 2. So in this, we just solved that K is 2, so P is equal to 2 over Q. And then it says, find the equation that relates P and Q. Oh, okay. That was easy. Let's try 328. 328. 328. A car's value varies inversely with its age. So there's value and there's age, and they vary inversely. So V is equal to K over A. Okay. Jackie bought a 10-year-old car, 10 years old, for $2,400. Okay, so let's solve for K. Multiply both sides by 10 to get K alone. Or you can do your little cross multiply trick. Cross multiply. So K is equal to 24,000. So now when we rewrite this, we would say V is equal to 24,000 divided by A. So that's our relationship. That's the answer to part A. Write the equation that relates the car's value to its age. So that's right here. Now B says, what will be the value of the car when it's 15 years old? So when age is 15. Okay, so just plug 15 in for A. So the value is equal to 24,000 divided by 15, which is equal to, calculator, 24023 divided by 15, 1,600. And there's our value. Okay. Not too bad. Whew. Okay. You should be able to handle 7.5 now.